Okay, guys, just a quick video to wrap up our exponential functions and what we've done so far. We've been looking at the actual graphs themselves and how they change, and basically how we could graph them. We started off with the zombies and we saw the difference between linear and nonlinear, and we made it even more specific when we found out this was called exponential function. Now, that original equation was just a times b to the x power. That's no longer the case on today's Desmos activity, you saw that it also changes by moving to the left and to the right with that h value. And then it also moves up or down with that k value. And I just wanted to reiterate how that move or how it moves. So what I've done here is on the Desmos graphing calculator, I was able to create this equation and all of these different sliders. I also wanted to put this reference point down to show you how it relates back to our movements. With exponential functions, it starts off really, really low and then it starts to shoot up, which we saw again in the zombie activity. There's something that I haven't shared with you about exponential functions. It never crosses into negative values if our k value is at 0. This is called an asymptote line. This is a line that the graph gets closer and closer and closer to, but never touches and never crosses. And actually, it'll do that forever and ever and ever. Now, if we zoom in on this line, you'll see it gets closer and closer and closer, but never actually touches. No matter how far we zoom in, it'll never touch. That asymptote line moves with the k value. Now the h value is our like y-intercept point. It's the x value of this intercept here. So we have 0, 0 as that h, k. Let me show you what happens when we move h around. As h becomes positive, our graph moves towards the right. Notice our h value here, 2, 0, h value is 2. So our exponential function would say x minus 2. If I moved it even further, I don't know, let's say 6. Notice we're at 6, 0 for this value. And it would say x minus 6 up there. So as h goes to the right, its numbers are getting bigger. Also notice it's a minus in there. So this is something kind of big when it comes to these transformations. Though that parentheses with the exponent x, x minus h. What that means is basically the opposite when it shows up on our graph. Minus h is a negative h, but if my h is positive, it goes to the right. Look what happens when it's negative. It goes to the left. Negative 6 here means we would have a plus 6 up here in the parentheses. So something tricky about the h's. Now, if we ignore the h's for now and we just focus on the k's, this is a little more straightforward. Notice what happens when I slide the k around. It moves up as I go more positive, and it moves down as I go more negative. This follows our instinct a little more, right? If I'm positive, I'm going up. I'm dealing with these positive numbers. If I'm negative, I'm going down. I'm dealing with those negative values. And it would show up exactly like that in our equation. If my k said plus 6, okay, I can move that k to positive 6. If my k said minus 3, okay, I would move that over to minus 3. So that k value is a little more intuitive. It's easier to remember than the h value because whatever you see there, that's how much you moved up or down. For the h value, whatever you see, it's the opposite direction on how much you moved left or right. So there's two of the movements. You have up or down, left and right. K moves us up or down, h left or right. Now, for the a and the b value, we saw that a value, and we noticed that's our y-intercept. So if my y-intercept was 6, then my a value was 6. If I had a negative a value, let's say -5, then my y-intercept was -5. Now notice that only is going to work when your k value is 0. Because right now my a value is 3, but since I moved k up, my y-intercept is 6. So tricky kind of stuff there. One thing to focus on, those a values, something you should take away. If you're positive, your graph is curving up, right? And the higher the a value, the more steep your exponential function is. Notice what happens when it goes negative. It goes down and it drops off drastically. Our asymptote line is still the same thing. We're still right at that 0. We get closer, but we never cross, we never touch. But the direction that it's going is based off of a, whether it's positive or whether it's negative. One other thing to keep track of is the b value. That b value tells us if we're growth or decay. And just like the a value, if it gets larger, then our graph gets steeper. But notice we don't really have negatives for b. What we do have is decimals. And when I have decimals, when I have those fractions between 0 and 1, my exponential function switches from growth to decay, where you start off tall, but then you get smaller and smaller, and then you continue to get smaller and smaller as you get closer to 0. And that's the gist of it there, guys. This is what I was trying to get us to see in our Desmos explorations. We saw a times b raised to the x power. And now just today we saw that h value moves us left and right, that k value moves us up or down, and a, positive versus negative, whether it's going up or going down, and then b, positive versus decimals, shows us if we're a growth or if we are a decay graph. Shoot me any emails if you have any questions about this stuff. Thanks so much, guys.